In this new playlist, I want to combine the ideas of computational argumentation, things like argument mining and those stuff, with the topic of discourse parsing. So because they are closely related to each other, and discourse parsing, the topics like first we should do segmentation, discourse segmentation, and then parsing. So they are related to each other. And there are two great books, but there are many great books. This one is really philosophical, but this one very practical for historical purposes. It is better to start computational argumentation from Argumentation Mining by Manfred Stede. I think he's in Pittsburgh University in Germany. I don't know if I'm right. And computational argumentation is an intersection of NLP, multi-agent systems, and reasoning. That's why it's really challenging. And it is really essential for future practical artificial general intelligence. So argument mining is a combination of NLP and reasoning, knowledge representation and reasoning. And it's a combination of linguistics and computer science, you might think. And this British philosopher and Tolman, the British guy, invented a model for argument. And I think it was in World War II. I'm not sure. But what you need is just grounds, claim, and rebuttal, warrant, and backing. So ground is just data, the evidence that you need. For example, you hear barking because it's an evidence. But the qualifier is not essential, but it shows the probability. For example, what are the chances? For example, 20%, 90%. So chances are, and warrant is like reasoning. So dogs are animals. We are doing some kind of reasoning that bark and. So backing is, sometimes we use backing, but backing is different from warrant. So in backing, you know that, for example, you know that your neighbor Tom has 2 large German shepherds. That's why you are reasoning with warrant. Another example, for example, you say you have the grounds that the sun is going down, but your claim is you should put a sweater on. In order to go from grounds to claim, we need warrant. We need reasoning. And our reasoning is like this. It gets cold when the sun goes down. Another example, so data is why is the conclusion true. But claim is the conclusion you want to draw. And for that, you need warrant. So why is the data relevant to prove the claim? What's the link? And qualifier and backing, as I said, you can just omit them, but they are not essential. But you can also use it. And finally, there are lots of ideas how you can use this the deep learning to understand and classify these things. For example, this one has some inputs: premise, claim, warrant 1, warrant 2. But there are many ideas. It's not just this model. I took this model from a PhD thesis, but there are many ways that you can think about it. And argument mining, as I said, is a combination of NLP and reasoning. So what is discourse coherence? In different contexts in language theory, each person has a different definition of discourse. But what I want to say is a definition from people in Stanford, I guess. Language does not normally consist of isolated, unrelated sentences, but instead of collocated, structured, coherent groups of sentences. So it's not a bunch of text that you just pick from random sources. It's not like that. You have a kind of argumentation. You want a kind of reasoning. You want to do some kind of reasoning. And we refer to such a coherent, structured group of sentences as a discourse. And real discourses exhibit both local coherence and global coherence. It depends on your granularity, going from coarser level to finer levels. So local coherence, you have some relations. For example, first sentences are clauses or real discourses are related to nearby sentences in the systematic ways. For example, consider this example from Hobbes. John took a train from Paris to Istanbul. He likes spinach. This sequence is incoherent because it is unclear to the reader why the second sentence, he likes spinach, follows the first. What does liking spinach have to do with train trips? But the second sentence is coherent. Why? Because Jane took a train from Paris to Istanbul. She had to attend a conference. So that's the reason that he took a train. So you see, it has a kind of reasoning behind that. So what is centering? Centering theory is very deep, goes back to 1998. And so a second way a discourse can be locally coherent is by virtue of being about someone or something. So, for example, a topic, and that is the idea of topic segmentation. Do you have a text? You want to know what is the salient point, what is the most important entity in that, so that all of the word, all of the sentences are talking around that idea, that salient point, which is on the center. So we have many different ideas, but one of them is central. The other one are around it. So that's why this one is a salient entity. For example, John wanted to buy a piano for his living room. Jenny also wanted to buy a piano. He went to the piano store. It was nearby. The living room was on the second floor. She didn't find anything she liked. The piano he bought was hard to get up to that floor. And finally, let's talk about local coherence, but topically coherent. So discourse can be locally coherent by being topically coherent. The nearby sentences are generally about the same topic and use the same or similar vocabulary to discuss these topics. Because topically coherent discourses draw from a single semantic field or topic, they tend to exhibit the surface property known as lexical cohesion, the sharing of identical or semantically related words in nearby sentences. For example, the fact that the words house, chimney, garret, closet, and window, all of which belong to the same semantic field, appear in the two sentences, or that they share the identical word shingle, is a cue that the two are tied together as a discourse. So this example, before winter I built a chimney and shingled the sides of my house. I have thus a tight shingled and plastered house with a garret and a closet and large window on each side. There are two commonly used models of coherence relations. One of them is Rsd, rhetorical structure theory, and that's different from rhetorical theory of Aristotle those things. Of course, they are related, but this is a new theory in computer science. And the other one is Penn Discourse Tree Bank, which is easier, I think, in comparison. Of course, we cannot say easier. They have different attitude and approaches towards this coherence relations. So, for example, each time we have a nucleus and some satellites like elaboration, evidence, reason, attribution, list, and so on. So, in Rsd, rhetorical structure theory, relations are defined between two spans of text. Generally, a nucleus, for example, this is a nucleus, and a satellite. So, the nucleus is the unit that is more central to the writer's purpose, and that is interpretable independently. But the satellite, for example, this is satellite, these are satellites. The satellite is less central and generally is only interpretable with respect to nucleus. And this goes back to the 2000, the year 2000 by Daniel Marco, and it has more than, I think, 50,000 citations or so. So there are some relations. As I said, reason. The nucleus, for example, Jane took a train from Paris to Istanbul. This is the center. So it's a nucleus. So the satellite could be, she had to attend the conference. So the relationship could be a kind of reasoning. So the satellite is the second sentence and the nucleus is the first. Another kind of relation is elaboration, because this is elaborating this sentence. So the satellite sentence, which is the second sentence, she lived in the midst of the great Kansas, is elaborating that Dorothy was from Kansas. So it is talking more about, elaborating more about Dorothy. Another kind of evidence is, another kind of relation is evidence. So his car is parked outside is an evidence for this nucleus, which is Kevin must be here. And there are two more relations, attribution. So we say that analysts estimated that this is attribution. What is the source of your claim or anything? And that sales at the U.S. store declined in the quarter. This is the nucleus. And list, sometimes you don't have a nucleus and satellite. We have two nucleus, but they are not related to each other either. We cannot say that they are contrast or comparison or anything. But we use them in sentence, in a text. For example, Billy Bones was the maid, Long John, he was quarter. For example, you're explaining a movie, so you want to explain the characters, so they are independent, and you don't have any argumentation or contrast or comparison in mind. And rhetorical structure theory, for example, this example, Kevin must be here. So his car is an evidence to this. So these are relation. So evidence is a relation. So here, the asymmetric nucleus-satellite relation is represented with an arrow from satellite to the nucleus. And nucleus, satellite, nucleus. And we learn them. We use deep learning. There are many ways that I will explain in lecture 3 and 4 and 2 about how can we create such a tree like this. And so there are some elementary discourse unit. For example, the first one, you can segment it like this. The European community until here. So this is the boundary, because this is the last word of this sentence. And then not a sentence, it could be just a sequence of words. But we segment them in order to see the relationship between these elementary discourse units. So there are 16 classes: attribution, background, cause, comparison, condition, contrast, elaboration, enablement, and each one has lots of classes as well. So, but in general, we have 16 classes. So 7 classes here, 5 classes here. We need 4. So four classes here. So, for example, background is circumstance, cause, result, consequence. For example, condition, you have contingency and hypothetical. In contrast, you have elaboration. You have enablement, for example, purpose. What is the enablement of that? And so the discourse tree looks like this. I think it's crystal clear. But the other data source, which is really from historical purposes, is very important. I think it's from 2000 or 2005, maybe 2005. So PDTB labeling is lexically grounded. So it uses these connectors as a result. So it's much easier. It doesn't care about the global structure, but it is really fast. It's easy to find these connectors, but you should know about word disambiguation theory, and you should use deep learning for classification of word disambiguation. That I will not talk about it because it's so easy. It's just a deep learning, and disambiguation is just a classifier. Because each word can have a different sense, and you classify it. For example, sometimes it has meaning 1, sometimes it has meaning 2, and so on. So not all coherence relations are marked by an explicit discourse connective, and so the PDTB also annotates pairs of neighboring sentences with no explicit signal. And the final dataset contains only 18,000 explicit relations and 16,000 implicit relations. Oh, this is Edu segmentation for Rsd parsing. So we are saying that when we break, for example, this is the break. So Mr. Rambo says. So this is the boundary of the first sentence. So the next elementary discourse unit starts from here on. So this is the boundary. Use a simple encoder. There are many ways I will explain in lecture 2, 3, and 4. Based on pointer networks and based on GRU, attention, different kinds of attention, global, local, and it is really beautiful. Elementary discourse units, as I said, you just segment a long sentence or a couple of sentences with some units so that you can see what is the relationship between these units. And Rsd parsing, so Rsd parsing, we use, just like dependency parsing, we can use shift reduce here as well. But what is reduce? What is your action? Your action could be, for example, attribution and satellite nucleus. It could be elaboration. So you're talking about what is the relation, and the second coordinate is your direction, going from nucleus to satellite, going from satellite to nucleus. So the second one is so this is the direction. So this article is really interesting. Transition-based neural Rsd parsing with implicit from China. And so it uses this idea of shift reduce